Okay, hello friends. In this class, we discuss about the questions asked from second year concepts, which in JEE mains examination in the first session, which is conducted on 23rd 1 2025. Okay, the first question, that means the 12th question, according to our serial number, two charges 7 microcoulomb and minus 4 microcoulomb are placed at 7 centimeter, 0, 0 and 7 centimeter, 0, 0 respectively. Given epsilon naught equal to 8.85 into 10 power minus 12 coulomb square per Newton meter square. The electrostatic potential energy of the charge configuration is, this is the question. Okay, there are two charges to see. First charge is what? 7 microcoulomb, Q1 equal to, this is the another charge, say Q2, which is equal to minus 4 microcoulomb. Okay, their coordinates are given. What are those? 7 minus 7 0 0 7 0 0. Okay, so what is the electrostatic potential energy of the charge configuration? Actually, these two charges are separated some distance, say called this is Q1, this is Q2, so it equal to R12. So according to definition of electrostatic potential energy, the energy stored, that means the work done to make a charge configuration, will be stored in the form of what? Electrostatic potential energy. So according to that equation, U is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R12. That means the distance between these two charges. Okay, right, here to see, that implies U is equal to 9 into 10 power 9. Why? Because 1 by 4 pi epsilon naught equal to 9 into 10 power 9 into Q1 is equal to what? 7 micro means 10 power minus 6 into Q2 minus 4 into 10 power minus 6 by R12. Here R12 is the distance between these two charges, but these two charges are, their position vectors are given, so that R12 is equal to, you know, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Therefore, that means R12 is equal to under root x2 is equal to what? 7, x1 equal to what? Minus 7 plus 0 minus 0, why? Because y1 equal to 0, y2 is equal to 0 whole square plus 0 minus 0 whole square. Therefore, R12 is equal to what? 14. What is it? R12 equal to what? 14 centimeter. Therefore, you can replace R12 by what is that? 14. That implies U is equal to 9 into 10 power 9 into minus 28 into 10 power minus 6 by R1 equal to what? 14. What is it? 14. It's in meters, 10 power minus 2. This one time, this is 2 time. Therefore, U is equal to 18 into 10 power 3, isn't it? 18 into 10 power 3. Okay, 18 into 10 power 3 minus 12 where? Minus 6 minus 6 minus 12. So it is nothing but what I say? Minus 3. Therefore, U equal to what? 0.18 joule. Sorry, 1.8 joule. 1.8 joule. That's it. The 13th question. The refractive index of the material of a glass prism. What is that? Given refractive index of a glass prism equal to what? Minus 3. Sorry, root 3. The angle of minimum deviation is equal to, angle of minimum deviation is equal to angle of the prism. Angle of the prism. What is the angle of the prism? Then angle of prism A is equal to what? This is the question is asking. You know, from definition of refractive index of a glass prism, mu is equal to sine of A plus delta m, that means minimum deviation by 2 by sine A by 2. Therefore, mu is equal to sine A plus A by 2. Why? Because delta m minimum, that is minimum deviation is equal to angle of the prism by sine A by 2. Therefore, mu is equal to sin A by sin A by 2. You know, in trigonometry we have a formula sin A is equal to 2 sin A by 2 into cos A by 2. Therefore, mu is equal to 2 into sin A by 2 into cos A by 2 by sin A by 2. So, this sin A by 2 sin A by 2 cancel. You know, mu is equal to what? Root 3. Therefore, root 3 is equal to what? Cos A by 2. You know, what is the value of cos? That means cos 60 degree is equal to what? Root 3. Okay, cos this one, cos this one, what is that? Sorry, mu is equal to what? Mu root 3. Yes, root 3 is equal to cos A by 2. Then root 3, that means root 3 by 2. Root 3 by 2 is equal to what? Cos A by 2. Root 3 by 2 is equal to what? Cos A by 2. Okay. Okay, so that why? Because 2 is there, so that's why I would like this 2 is brought into this side, root 3 by 2. That implies A is equal to what? 60 degree. Okay, that's it. Okay, the 14th question, the equation of a transverse wave traveling along a string is function of position and time 4.0 sine into 20 into 10 power minus 3x plus 600 into t millimeter, where x is in millimeter and t is in second. The velocity of the wave is, you know, one thing, this is a string. Along this string a transverse wave, a progressive transverse wave is propagate, okay, which is represented by an equation y of x comma t is equal to a sine kx minus omega t, okay, along positive x axis. This is the equation of a transverse wave propagate along the positive x axis. Okay, now what is given? Given equation y of x comma t is equal to 4.0 sine 20 into 10 power minus 3x plus 600 t. Sorry, okay, where x is in. So, what is the velocity? Now, compare both equations, then we get k is equal to what? K is the wave constant, k is equal to propagation constant, that means 20 into 10 power minus 3 millimeter, and omega is equal to what? Minus 600. What is that? Minus 600, okay, per second, radians per second, okay, right. So, we know velocity of a progressive wave along a velocity of a transverse wave along a string v is equal to what? Omega by k, angular velocity by wave, that is propagation constant k, v is equal to what? Omega by k. Omega is given, what is it? Minus 600 by k. K is equal to what? 20 into 10 power minus 3. You know, millimeter, which is converted into meter, which is nothing but 10 power minus 3 meter, isn't it? So, 2 1 ja 2 3 ja, that means minus 3 into 10 power 6, minus 3 into 10 power 6, okay. Okay, so which is in you may write, which is in write like this, minus 3 into 10 power 6, okay, right, or in positive x direction, positive along the positive x axis. Why? Because we get the this value is equal to negative, that represent what? Along the positive x axis. So, v is equal to, therefore, v is equal to what? Minus 30 meter per second, okay, right. Sorry, this is 3r, this is 3 into 3, okay, isn't it? Right, that's it. The 15th question. In photoelectric effect, an electromagnetic wave is incident on a metal surface. Suppose to say this is a metal surface. On its surface, an electromagnetic radiation is supposed to be incident. Then what happens? Electrons are ejected. This phenomena is called photoelectric effect. Okay, the minimum energy required to eject the photoelectrons from the metal surface is called work function. Okay, so the work function of the metal is given. That means work function. Okay, W is equal to what is given? 2.14 electron volt, and stopping potential V naught is equal to 2.14 electron volt. Stopping potential is 2 volt here, 2 volt. What is the wavelength of electromagnetic wave? Wavelength lambda is equal to question mark. You know, this is obtained from Einstein's photoelectric equation. What is that? The incident radiation means the energy of a incident photon is equal to do some work, that is called work function, and remaining is converted into its kinetic energy. So, this is energy, instant photon energy, that means instant electromagnetic radiation energy. E is equal to work function, it is given. What is that? 2.14 electron volt plus half m square, which is equal to what? E into V naught. That means kinetic energy of a ejected electron is stopped by applying some voltage, that is called stopping potential. Okay, so you may calculate it, but you know E is equal to what? Hc by lambda is equal to 2.14 electron volt plus V naught is a 2 volt, that means 2 into E into V, 2 electron volt. That implies Hc already given in the question. What is the Hc is equal to 1242 electron volt nanometer by lambda is equal to 4.14 electron volt. 4.14 electron volt. Okay, therefore lambda is equal to 1242 electron volt nanometer by 4.14 electron volt. This electron volt is cancel, then remaining while you solving 4 3 are approximately 3, that means when you get it 300 nanometer. That's it. Okay, the 16th question. 2 point charges minus 4 microcoulomb and 4 microcoulomb constituting an electric dipole are placed at minus 9, 0, centimeter and 9, 0, centimeter in a uniform electric field of strength 10 power 4 Newton per coulomb. The work done on the dipole in rotating it from equilibrium through 180 degrees centigrade, 180 degree is, okay, this is asking. You know, this is a uniform electric field. We all of you very well, a uniform electric field is represented by equally spaced straight lines. In this, okay, uniform electric field, an electric dipole is nothing but separation of two unlike charges having same magnitude, okay, very small distance. So, this is electric field direction. We know electric field is always from positive to negative, isn't it? So, this is a positive. So, this negative field is try to rotate along its direction. This negative is try to attract towards the positive like this. So, these two are same in magnitude but opposite in direction. So, they are constitute a couple. Okay. So, what is the work done on dipole in rotating from equilibrium through 180 degrees? This is asked. Okay. You know, this work will be stored in the form of what? Energy. The work done on the dipole, okay, the work done on the dipole the work done on the dipole by an electric field is stored in the form of potential energy, which is equal to U is equal to minus Pe cos theta. What is it? Minus Pe cos theta. You know, this is rotating from equilibrium through 180. That means delta U is equal to UF minus UI. So minus Pe cos equilibrium, from where to where? 180 to equilibrium. That means cos 180 final 180 minus Pe cos 0 degrees. Therefore, delta U is equal to minus Pe cos 180 degrees plus Pe cos 0 degrees. Okay, minus Pe into cos 180 minus 1 plus Pe into 1. So, delta U equal to what? 2 Pe. That implies delta T is equal to 2 into P is into P equal to what? Q into R into E. Therefore, delta U is equal to 2 into charge of either one, Q1 equal to minus 4, Q2 equal to what? 4. Okay, so I would like to take 4 into 10 power minus 6. Why? Because microcoulomb. Micro means 10 power minus 6 into R. R is the, what is the separation distance between these two? 9 minus of minus 9 into electric field intensity 10 power 4. Therefore, delta U is equal to 2 4 ja 8 into 10 power minus 6 into 9 plus 9 18 into 10 power 4. Okay, that implies delta U is equal to 18 8 ja 164, sorry 144, isn't it? That means 144 into 10 power minus 2 joule, isn't it? Right, that's it. So, which is equal to 144 minus 2 into 10 power minus 2 joule. Okay, but in the examination it is asking millijoule. Therefore, delta U is equal to, milli means what? It is chhod gaya, that means 14.4 millijoule. This is the answer for this question. Okay, right. The 17th question. A galvanometer having a coil of resistance 30 ohm need 20 milliampere of current for full scale deflection. If a maximum current of 3 ampere is to be measured using this galvanometer, the resistance of the shunt to be added to the galvanometer should be 30 by X ohm, where X value is what? You know very well, this is a galvanometer. Okay, this galvanometer is very sensitive. Okay, whose resistance equal to what? 30 ohm. Okay, which is needed to measure, that means which is measure 20 milliampere for a full scale deflection. Now, you want to convert this galvanometer into a ammeter which measures maximum current is what? 3 ampere. So, then what you can say, it may be shunted by a small resistance parallel to it. This is conversion of moving coil galvanometer into ammeter. You know, galvanometer is ammeter, both are electronic devices which are used to calculate electric current. Okay, but ammeter is capable to measure more current compared to galvanometer. Okay, so suppose this is the current I drawn from the main. When some of the current is passes through galvanometer, rest means what? I minus Iz current is passes through the shunt resistance, its value is equal to what? Rs. So, here what happened, these two are parallel. So, potential drop across ends of this galvanometer is equal to potential drop across this shunt resistance. Therefore, Ig into G is equal to I minus Ig into Rs, isn't it? Here Gs means what? Galvanometer resistance, Gr. Okay, this is called shunt principle, that means conversion of galvanometer into ammeter. Okay, here Ig is given. What is the Ig value? what is that? 20 milliampere. What is that? 20 milliampere. So 20 milli means 10 power minus 3 into galvanometer resistance. What is the galvanometer resistance? It already directly given. What is that? 30 is equal to I minus Ig. What is that? I is what? Maximum current is supposed to be measured by this ammeter is 3. Ig already given. What is that? 3 minus 20, that means 0.02, okay, into Rs. This is the value is required, shunt resistance is required. Okay, so what is value? 600 into 10 power minus 3 is equal to what is its value? 2.98 into Rs, isn't it? 2.98 into Rs. Therefore, Rs is equal to 0.6 by 2.98. That implies 600 by 298, isn't it? But this is Rs is what? Given 30 by x. Therefore, 30 by x is equal to 600 by 298. That implies x is equal to 30 into 298 by 600. When you solve this one, 3 over 0, 20. While doing it, it may get the value is equal to what? Approximately 149 ohms. Okay. So, this much big resistance is supposed to be connected parallel to galvanometer, then it is converted into an ammeter. Okay, right. The 18th question, assertion and reason type. What is that? Assertion is given. The binding energy per nucleon is found to be practically independent of the atomic mass number A for nuclei with mass numbers between 30 and 170. You know, first, what is assertion? What is given? The binding energy per nucleon. Binding energy per nucleon. That means binding energy per nucleon. That means this is nothing but a delta m c square by binding energy per nucleon. What is that? Nucleon means what? Total mass number A. Okay. The value of binding energy per nucleon is nothing but, it is nothing but a packing fraction. What is that? Packing fraction. That means the energy required to combine the nucleons, okay, or the energy required to split the nucleons, okay, splitting the nucleons, isn't it? So, when you draw a graph between binding energy per nucleon in binding energy per nucleon in million electron volt to the mass number A, okay, in that means beginning, that means 1 to in between 1 to 20, it vary very drastically, but when it changes, that means when it is starting from 26 onwards up to 250, the graph is slightly vary, that means approximately in between 30 to 70, that means 170, it is approximately, it is independent. Okay. So, binding energy per nucleon is given stability of the nucleus, Okay. So, according to given assertion, which is correct. Next one is called reason. Nuclear force is long range nature. You know, nucleons are what? Nucleons are the protons and neutrons too. These two are collectively called nucleons because these two are lies inside. Actually, these protons are electrostatically repulsive in nature, but these protons and neutrons are lies inside the nucleus, then exists the nucleus, there is existence of atom, okay, then existence of matter. That means the nuclear forces are very strong in order of 10 power minus 15 meter, is nothing but 1 Fermi. Within this range only they are very strong. Okay, when nucleons are come outside the nucleus, okay, they becomes decay, they can destroyed. That means absorbed by some other materials. That's why nuclear forces are very short range in nature. In the available 4 fundamental forces, okay, what are those? Gravitational, electric, magnetic and nuclear. Among these 4, nuclear forces are very strong, but in short range only. These are not a long range forces. So reason is wrong. So assertion is correct, reason is wrong. Okay, that's it. Okay, the 19th question. What is the current through the battery in the circuit shown below? Okay, in this given circuit there are 2 diodes are there. This is diode D1, this is diode D2. Okay, here to see, this is the positive terminal of the battery. The current starts from positive, while reaches this point, okay, the current is distributed. You know, this is P type semiconductor, this is N type semiconductor. So this is P and simply this is N. So in these 2 diodes, positive terminals are connected to positive, this is negative terminals are connected to negative. Then we can say this diode here diodes PN junction, okay, PN junction diodes are in forward bias, so that they are allowed to flow the current through them. Okay, so that this circuit is redrawn like this. This is a resistor 20 ohm, this is the resistor again 20 ohm. Okay, these 2 are connected to a battery. This is what 5 volt. So that you want to calculate current. So first you know what is the total resistance in the circuit. Total resistance in the circuit R equivalent is equal to what? These 2 are in what? Parallel. So in parallel connection, what is that value? R1 R2 by R1 plus R2, that implies 20 into 20 by 20 plus 20. Okay, that implies 400 by 40. Okay, what is the resistance? 10 ohm, isn't it? And voltage V is equal to what? 5 volt. Therefore current I is equal to what? V by R equivalent. V means what? 5, R equal to what? 10, equal to what? 0.5 amp. So this is the current in this circuit, right? The 28th question. A plane electromagnetic wave of frequency 20 megahertz travels in free space along the positive x direction. Okay, this is an electromagnetic wave propagate along the positive x direction. Okay, at a particular point in space and time, the electric field vector of the wave is Ey. This is the electric field vector wave. Okay, what is that? Ey along the y axis equal to what? 9.3 volt per meter. Okay, right. Then the magnetic field vector at that point Bz is equal to what? Why? Because x is the resultant, that is called, what is electromagnetic wave? Electromagnetic wave is nothing but resultant of electric and magnetic vectors. Okay, when electric vector vibrates along the y axis, magnetic vector vibrates along the z axis. So the resultant is properly along the positive x axis. This is according to the given question. Okay, so you know Bz is equal to what? But you know electromagnetic wave velocity, it is propagate equal to velocity of light 3 into 10 power 8 meter per second. Okay, from the relation between okay, magnetic field, okay, electric and speed of light is equal to what? Speed of light equal to what? E by B. What is that? E by B. If suppose speed of light, electromagnetic wave is propagating along the x axis, it is y axis, it is nothing but z axis. That implies magnetic component of vector. That means what is asking? Then the magnetic field vector Bz is equal to Ey by Cx. Ey, what is that? 9.3 by C, 3 into 10 power 8. 3 3 ja 3 1 ja into 10 power minus 8 Tesla. Okay, right. Okay, the 21st question. A concave mirror of focal length f in air, okay, supposed to see in air. This is a concave mirror. Okay, its focal length, you know, its focal length f. This is radius of curvature. A concave mirror of focal length f is equal to r is equal to 2f. R is equal to what? To f. That implies f is equal to what? 1 by r. So focal length is depends only on radius of curvature. Radius of curvature. To see. Next, what happened? The same concave mirror is dipped in liquid. Suppose now what happened? The same concave mirror is now, okay, kept inside a water. Kept inside a water. Okay. So even it is kept inside water, its radius of curvature does not change, its focal length is also not change. Okay, this is in water. So what happened? R is equal to what? Same to f. That implies focal length equal to what? 1 by r. Okay, right. That means what? Focal length of a mirror is depends only on its radius of curvature, but not on its refractive index. Okay, so its focal length in the liquid will be, therefore focal length in the liquid equal to what? Same f. That's it. There is no change because focal length of mirror will not change because focal length of mirror does not depend on the medium. Okay, it is depends only on its radius of curvature. That's it. And the 22nd question. At steady state, the charge on the capacitor as shown in the circuit below is dash microcoulomb. To see what is the charge across this 8 microfarad battery, from definition of capacitor, from C is equal to what? Q by V. Therefore, Q is equal to what? C into V. Here C is equal to what? Capacitor capacitance. Capacitor capacitance. V is equal to what? Potential difference across capacitor. Okay, and Q is equal to what? Charge across capacitor plates. Capacitor plates. So you want to calculate charge across the capacitor plate, that means at a steady state. What is the charge? You want to know what is the capacitance, already given, its capacitance equal to, but you don't know the potential drop across this capacitor plate. For that you can use the next diagram. Okay, you know, you can disconnect this capacitor. So what happened? The current starts flowing from positive end. While it comes to here, what happened? Same current is passes through the 10 ohm as well as 15 ohm. So total current in the circuit, okay, I equal to what? V by R equivalent. That means net resistance. What is the net resistance? Here R net equal to what? R1 plus R2. What is it? 10 plus 15 equal to what? 25 ohm. Therefore, current I is equal to what? V is equal to what? 5 by R net equal to what? 25. Then what is the value? 1 by 5 is equal to 0.2 amp. Okay. So what is the potential drop across this 10 ohm? Therefore, PD across 10 ohm resistor is V is equal to what? I into its resistance. Therefore, V is equal to, what is the current? 0.2 and resistance equal to what? 10. Okay. then equal to 2 volt. Here to see the 8 microfarad capacitor is connected across this 10 ohm resistor, so that the potential difference across this 10 ohm resistor is equal to potential difference across 8 ohm. Here 10 ohm and 8 microfarad capacitor are in parallel, so that same PD across both. Therefore, the required charge on capacitor plate at steady state Q is equal to, see what is it, 8 into 10 power minus 6 farad into, okay, into V, potential drop across this 8 equal to 10 ohm, which is equal to what, 2 volt. That implies Q is equal to what, 16 into 10 power minus 6 coulomb, okay, which is equal to what, 16 micro coulomb. So this is the answer for this question, right? The 23rd question, in a series LCR circuit, this is L, this is C, this is R, these three LCR in a LCR circuit of resistance how much, 300 ohm, capacitor 25 nanofarad, okay, an inductor of 100 millihenry are used for maximum current. Suppose this is connected and alternating source of E is equal to E naught sin omega t in a series LCR circuit, okay, connected for maximum current. This is the condition for maximum current, okay, circuit at resonance condition, circuit is at resonant condition, okay. So at resonance capacitor reactance is equal to inductor reactance, capacitor reactance is equal to what, inductor reactance. That implies capacitor reactance is equal to what, 1 by omega C is equal to inductor reactance omega L. That implies omega is square equal to what, 1 by LC. That implies omega into equal to what, 1 by root LC. So at this there is a maximum current, okay, supposed to be travel. Therefore the angular frequency omega is equal to 1 by root L. Inductor, what is that, 100 into 10 power minus 3 Henry, okay, into C capacitor. What is the capacitor, 25 nano 10 power minus 9 farads, 10 power minus 9, okay, right. Then when you do it, you get the value of 10 square 10 power, that means 1 by root over 10 power minus 1 into 25 into 10 power minus 9, that means 1 by 2 root 5 means what, 5. When you go to the numerator, its value is equal to what, approximately 2, okay. This is the answer for this question, okay, right. The 24th question, what is that, a time varying potential difference is applied between the plates of a parallel plate capacitor. Suppose to see this is a parallel plate capacitor, to its plates a time varying, okay, its capacitance C is equal to what, 2.5 microfarad, okay. Across its a time varying PD is applied, E is equal to E naught sin omega t, okay. The dielectric constant of the medium between the capacitor plates is 1, that means air is there, there is no dielectric, that means air is there, okay. It produces an instantaneous displacement current ID. What is produced, 0.25 milliampere, Okay, right. In the intervening space between the capacitor plates. Okay, the magnitude of the rate of change of potential difference. The rate of change of potential difference is equal to what? This is asking. From when you start when the capacitor plates are connected across the alternating voltage source, capacitor plates starts charging, then capacitance is increases. So from definition of capacitance is equal to what? Q by V. Okay, therefore Q is equal to what? C into V, isn't it? Okay, C into V. Okay, due to intervening space, there is a current is developed, that is called displacement current. I is equal to what? Dq by dt. Therefore id, displacement current, that should be developed across the capacitor plates, in the space between the capacitor plates, that means intervening space between the capacitor plates. Id is equal to d by dt of Q is equal to what? C into V. That implies Id equal to C into dV by dt, isn't it? Because capacitance is constant. Okay, therefore dV by dt is equal to Id by C, that means displacement current by capacitance. So Id is given, what is that? 0.25 milli means 10 power minus 3 ampere by capacitance 2.5 micro 10 power minus 6 farad. Okay, right. Then you get the answer will be 100. What is that? 100. That's it. Volt per second. Okay, right. The 25th and last question in this evening shift of 23rd 1/20/25 mains examination is the width of one of the two slits in Young's double slit experiment. In Young's double slit experiment, okay, at this region, okay, fringe, that means fringe pattern, that means alternative bright and dark fringes are supposed to be so formed. Okay, this is a screen, the distance between screen and this is slits is nothing but what I say, capital D. So what is the fringe width? Beta is equal to lambda d by d. Okay, very well. So what is given? The width of one of the two slits in Young's double slit experiment is d, while that of the other slit is xd. This slit is width is small d. This is equal to what? Xd. That means d1 is equal to d, d2 equal to what? X into d. If the ratio of the maximum to the minimum intensity is what is that? 9 by 4. Then the value of x is, from Young's double slit experiment, due to interference of two light waves, the intensity I, that means intensity I is always directly proportional to width square, width of the slit square. Okay, so you can make it convenient to maximum. Okay, you can component and dividend, you can do it. That means root over I1 plus root I2. This is called constructive interference. Then you get the maximum. That means what? Intensity is what? Maximum. That means you get the bright band. Intensity is minimum. That means both the waves are interfere, okay, destructively. This is called destructive interference. E is equal to, what is that? Width square. That means what? It is already given. What is that? Maximum. That means 9 by 4. Okay, so it may write root over I1 plus root I2, okay, by root I1 minus root I2 whole square equal to 3 by 2 whole square. This square is cancelled. Therefore, you get root over I1 plus root I2 by root I1 minus root I2 equal to what? 3 by 2. Its value is given, that implies xd plus x by xd minus x is equal to what? 3 by 2. That implies I would like to take d from this one, x becomes a common, or you can take this one is common, that means x d whole square plus, that means we get x plus 1 into d. This is not required for here. From this one you write x plus 1 by x minus 1 into d equal to what? 3 by 2, isn't it? This d is cancelled, therefore 2x plus 2 is equal to 3x minus 3. That implies 3x minus 2x is equal to 3x minus 2, that means 5. That implies x is equal to what? 5. Okay, that's it. This is the answer for this question. Okay, right. Thank you very much.